All right, we are going to work on solving a real world problem by using our graph of parabolas. So our problem we have today is a man jumps off a cliff into the water given the function that the function, or h of t, is negative 16t squared plus 16t plus 480, where t is time in seconds and h is height in feet. At what height did the man jump from? So we are going to start by using our Desmos to solve this. We will learn later at how to do it without Desmos, but we'll start here. So I need to enter in the equation. Now remember, ht is just a fancy way of writing y equals. So we'll type in y equals negative 16. We can't use h because this is a coordinate plane which deals with x and y. So we're going to do x squared instead of that t plus 16x plus 480. So we have this now graphed on here, which it's really hard to see. So I'm going to go in and I am going to change my settings. It looks like it kind of drops down here, so I don't need to go much higher on my x's, but for sure on my y's I need to go much higher. I'm going to go up to 500 for y, it's not 5,000, and see if that helps. There you go. Now we have kind of a nice graph of that. So I should be able to kind of answer these questions. The first question asked, let's see if I can jump back here. The first question asked is, what height did the man jump from? So if we look here and we try to read this, it said x was time and this is height. And doesn't it make sense that 0 time would be the height that he jumped? So we look up here, kind of hard to see that point. The nice things with Desmos, if you click on it, is there. So he jumped from a height of 480. If you look back to here, we see that 480 is right here. That is always going to be our y-intercept, or our starting height. Almost every one of these problems you're going to do, somebody's going to be throwing a ball or jumping or something like that, and it's going to make the same little path here. And we always know that the height that it started with is this last number there, the one without a variable. So we know he started at 480 feet. Our next question we need to answer is, I think it was, what was the highest that he has gone? Let's see. Oh, what was the highest point he reached? Well, if we look at our parabola, we're going to see that that vertex is a maximum. So we're just looking for the vertex. So right there, the highest point he reached was 484 feet. And that 0.5, because x stands for time in this one, was how long it took him. So at 0.5 seconds, or a half a second, he was 484 feet tall, or 484 feet off the ground. Our next one was, how many seconds did it take him to hit the water? Well, to me, this just makes sense visually if we kind of look at this, that he jumped and and he went all the way down here. And so we are looking that he hit the water at, well, that's kind of hard to see with my screen here. Sorry, guys. Looks like it was about, oh, sorry, I got to go even further down. You can't even see it there. It looks like it was about 6 seconds is when he hit the water. Now, over here would also make sense that's when he's in the water, because it's a 0. He's like at 0 height or with the water. But that -5 time doesn't make sense. We can't have -5 seconds. So this we kind of ignore. We really only are looking at the graph in this first quadrant. We're looking at it here. Sorry, it went off the screen because of that. And then that y-intercept. So again, just kind of looking here at what height did he jump from. That's going to be our y-intercept, which is always that last number right here, that 480. The highest point he reached is going to be our vertex, the y value of the vertex. The x value is the time that it was. And how many seconds did it take him to hit the water? That's going to be our x-intercept, because we're kind of looking at 0 feet above. All right, good luck.